Aloha! Welcome to Hawaii. I'd like to call it the world capital of the curvature because it's probably the best place in the world to observe the Earth curvature with our tall islands and it's surrounded by the sea level. Okay, so here's the Hawaiian island chain, starting with the big island of Hawaii. Here is Maui, the second biggest island. Here is Oahu, the most populated and popular island where we find Honolulu. Here is Kauai, which is probably the fourth biggest island and most populated island. It has its little brother Ni'ia, which is only populated by native Hawaiians. We also have Molokai here, Lanai, Kaolave, which used to be bombed like hell. And there are several other tiny little islands scattered around those bigger ones. And one in particular we're going to be looking at. It is an itsy bitsy teeny weeny little island called Molokini that I'm going to show you today. Sorry, I never could quit my day job. You can see Molokini here, tiny little crescent. Right next to McKenna Beach. Now, if you go to McKenna Beach, it's a really long, beautiful, they call it Long Beach, or Big Beach. Yeah, Big Beach and Little Beach. So if you go to Big Beach, it's nice and long, nice and flat water. You can play there all day. Or if the person who was taking this picture was standing on this cliff here, if you turn around, you look on the other side here, you have Little Beach, and you're not going to see many people with clothes on because it's clothing optional. So that's one destination you should keep in mind if you go to Maui. Maui. So we have a phallic looking male and female genitalia in the same island. You can see a bunch of boats, even kayaks, a lot of swimmers. It's a wonderful little island. And it's not very tall. Let's see, how tall is Molokini? About 160 feet, just about. That's at the crest, at the very top, one of its point, not down here in this dip. Okay? My map. And I was observing that from the Big Island, right over the town of Hawi on the Kohala Mountain Road, which is about above Mahukona. Take a little closer look here. Right below the highway. You can look at the elevation finder. Mahukona was right about here. What's the elevation up here? 1,197 feet. That's pretty low. Is that really that low? Because as I know, I'm about 1,600 feet. So this website is not so accurate. So I'm going to tell you that I was about 1,600 feet and I was observing Molokini. Okay. Let's look at how to calculate the curvature of the Earth. It's very important here because that's what we're talking about. Are we really on a ball Earth? Okay, I really like this website, how to calculate the Earth curvature, because it has a little drawing here. There are many websites you can look up on the internet how to calculate the Earth curvature, and they're going to present you a whole bunch of different websites, and they basically have the same answer here. 8 inches in 1 mile, or per mile squared, which is the formula. 8 inches per mile squared is the Earth curvature formula. If you can find a different formula, please let me know about it. So they started off, Robert, the expert here, was asked by another, who was the other? Who knows? At all level. So everybody wanted to know at every level what is the formula to calculate the Earth curvature. And Robert says, well, everybody knows that the Earth is a sphere of radius of 3,963 miles. The precise number here, we don't have 4,000 miles, we don't have 3,900 miles, it's 3,963 miles. Okay, how did they measure that? They must have pulled it right out of their... Anyway, so they use this radius and they want to know the height that's missing. So we shouldn't be able to see anything below that height if we're observing from this P point here, looking at a certain distance. Okay, and using the Pythagoras triangle, they get that. A little more precision, 7.98 inches to the foot. Let's do the math. Calculator, please. All right. 7.98 inches to a foot is what? 0.665. Okay, because we know that 8 inches to the foot is 2/3, which is 0.66666 periodical. So this number is a little bit smaller than 8 inches. And we'll stick with that just to be precise. Because it's important in mathematics to be precise. If you're doing economics, it's extremely important to be precise in numbers. Okay? Is it important for Robert to be precise? He gave us a precise number, didn't he? All right, so Molokini is 160 feet tall. Where I was standing was 1,600 feet. So let's go look at our observation here. So I'm just below 1,600 feet of elevation, as I tell you, because we just saw that the elevation finder tool was not so accurate. It's probably a better website, but I don't have much time to search right now. Somebody else could help me along the path, but it's not so important. Could it be important? We'll see. So here is Molokini, that little island here. And that's the shoreline of Maui on the right side. And here is Lanai. Here's the hill of Mekena, where separates Big Beach from Little Beach. We don't really need to go uphill on Maui so much right now. These are the windmills. What I want to show you is this here close-up look of Molokini. You can see Molokini in its whole height. See a little sailboat here. And you can see little waves splashing. And if you would observe good enough, the waves splashing, we can see that you see the shoreline of Molokini is just before the curvature line. So the top of the ocean here is what you could see. You could call it the curvature because we don't see anywhere beyond. We don't even see the island of Molokai behind there at the elevation I was, around 1,600 feet. Okay. Let's get back to our math here. I want a calculator. Where's my calculator? Well, first let's measure the distance. Sorry. Let's measure the distance of what we're measuring. So from up here, measure the distance to Molokini, 52.61 miles. We'll just stick to 52 if you want. There's my calculator. 52 miles, square that number, equals 2,704. Okay, we multiply that by 0.665, which is 7.98 inches to the foot, if you remember. So we shouldn't be able to see anything below 1,798 feet. Okay? Which is about 1,800 feet. So we're not supposed to be seeing anything below 1,800 feet. If I'm standing at 1,600 feet and I'm looking down towards Molokini and I can see the shoreline, so if I was sitting on the shoreline of Molokini and I was looking up to where I was observing from, I wouldn't be able to see where I was observing from because it's below 1,800 feet. So there's at least 200 feet of error here out of 1,800 feet. Is that a big margin of error? Not so much. But like I tell you, if you were an economist, you would be screaming to see such a big margin of error. Okay? So we're not supposed to see anything below, just below 1,800 feet. Bear that in mind. Okay. Let's look at another shot. Sunset view from the same observation point. Here's Ka'olave in the foreground, the darker one. Closest island to where I was standing. Here's Lanai with its top covered with clouds. And there's Mekena Hill on Maui. And here we have Molokini in the middle. Sunset view. You can kind of see that the shoreline is just before the curvature line. It's kind of hard to see, isn't it? But I'll show you a little bit better. You see any waves splashing now? Not so much. The ocean looks calm. Okay, do you see that? The difference? Not so much, huh? Not so much. Not enough to make a point. Okay, let's look at another shot. That's a clear morning here. Still in the same area, around 1,600 feet of elevation. Did I tell you honestly? Let's go look at Molokini here, a closer look. You can see the waves splashing on its shoreline. More obvious on a clear morning like that. See the nice white waves splashing on the shoreline. So therefore, if we see the shoreline, it has to be before the curvature of our Earth in the water, curved water. Oops, a little too fast. Okay, you can see again, it's just below the curvature line. Let me make my point a little bit more clear here as I drive up the highway a little bit. Okay, here I was standing right next to the sign on the highway that says 2,500 feet of elevation on the Kohala Mountain Road. You can see Lanai in his full height. Here is Kaulave, Lanai. Let's look at Molokini. Where's Molokini? Where's Molokini? Went too far, too fast. Okay, here it is. So we can see the shoreline here is definitely below the curvature. Okay? You can even see the island of Molokai back there past the shoreline of La Perouse Bay on Maui. But that's not, again, I'm making another video on that, on Molokai. But here we're still looking at Molokini. And here, it's not impressive map because I'm standing at 2,500 feet of elevation. So my observation falls before the curvature. Not so impressive, but just to show you the comparison. So here I went a little further on the highway, a little higher too, at right next to the sign that says 3,000 feet of elevation, right next to the Na'alapa stables. So here's Maui on the right side. You can see better Molokai back there, but like I'm telling you, I'm making another video just about Molokai back there. Past the shoreline of La Perouse Bay on Maui. What I want to show you is Molokini here. Get this out of the way. The Molokini right here. So you can see the shoreline is way before the curvature. And I'm standing at 3,000 feet elevation. We're not going to make the math here. It's not so impressive because we're falling before the curvature line, curvature level, from where we're observing, of course. See the barge here getting tugged by a little tugboat, delivering goods to the Hawaiian Islands. Okay, and this one. So this one, I just wanted to show you before that I am much further away. Actually, I'm going to use the elevation finder map to show you better where I was. So I was further on the island. Around here, on the upper highway between Kona, see the Kona airport, and Waimea, which is way up there. So it was somewhere along that line here. That's the elevation here. 1900, it's close to reality because I know it's about 2,000 feet of elevation. So I'm going to give it another 100 feet. Because I know it has a sign somewhere close there that it is 2,000 feet. And I was actually just below that. Okay? And the distance, let's measure the distance. Let's measure how far away we were as I was observing Molokini from the upper highway. It's around here where the black streaks are from the lava that flowed over 100 years ago. Measure the distance, please, to Molokini. 69 miles. Okay? Let's do some math. Pull out the calculator. 69 miles. 69 square. 4761. We multiply that by 0.665, which is 7.98 inches to the foot. So we shouldn't be able to see anything below 3,166 feet. If I were to stand on the shoreline of Molokini and I'd be looking towards my observation point, which was actually 2,000 feet, just below 2,000 feet. Okay? And remember, Molokini stands 160 feet tall. So let's take a look at it. You see the black streak of the lava? See it right along the highway? It's black, darker than asphalt. And from there, there's very few places you can stop on the side of the highway to get a view. Here's Ka'olave on the foreground. And I was trying to get a glimpse of something out there. Can we see Oahu? Can we see Hawaii if the earth is flat? But we all know it's not flat. And I'm proving it to you right now with showing you the curvature, and I'm also demonstrating that the other kind of people that think that we live on a globe spinning in space are also wrong. There's something else. We have to consider seriously in this world that we live between controlled opposition. Are we going to drink Coke or Pepsi? Are we going to vote Republican or Democrat? Are we going to watch Star Wars or Star Trek? Who cares? There's more than just two options. Now, if you're going to be voting Democrat or Republican, you're encouraging the evil politicians to step up and rule you in a free world. If you're going to be drinking Coke or Pepsi, you're going to be ingesting some, how they call it, phosphoric acid, which removes the calcium from your bones. So it's just like the government. It steals from your natural structure. All right, I want to see Molokini. Come on, where was I? Sorry. Get lost in my babble. Talking about Babylon. I'm looking for... Sorry, I should have made an observation before I showed you that. I forgot, it's been such a long time since I've seen this video. But I saw it. It's actually Hana on the east end of Maui, as we see here. Come on, Louis, wasting some valuable time here. Where is Molokini? I thought I had seen and observed it on this video, and I know I have. Sorry, I'm back again here, right between Ka'olave and Lanai. See the split between the two islands. Let's be a little bit patient with the camera pan there. Come on, camera, move. No, the other way. Jeez. Sorry, I should have been a little bit more prepared before breaking up this video. Sometimes I want to rush things. Put it out there, Louis. Hurry up. But no, if I show you a bunch of bull or things that are not so accurate, you're going to be commenting me left and right saying, what are you saying? You're so wrong. Where was it? Okay, here's McKenna. Come on. Okay, going there. I couldn't even see it with my eyes. The sun glaring in my eyes. But I kind of noticed at the very last minute, did I? Where is it? Please. Here it is. All right, we got it. Finally. You see it here? Can you recognize that shape? That's Molokini right here. I don't think we can see the shoreline. We definitely cannot see any waves splashing. Make them back or what? So I will admit, we cannot see the shoreline of Molokini at that point. So if I were to stand on the shoreline of Molokini here, I wouldn't be able to observe the highway so clearly where I was standing from. But you can still see most of the island. You can still see the tops that are 160 feet higher than the ocean level. And remember, my camera eye was below 2,000 feet. Okay? 2,000 plus 160 feet. We have what? About 2/3 of the value. We shouldn't be able to see anything below this number here, but we still see it about 2/3 of this value here. So around 2,000 feet, we can see what we see. You see that? It's kind of blurry. I'm not tricking any imagery here. I don't work for NASA. So there's your number. So we get 2/3 of the value of what we should be looking at. If I was an economist, I'd be probably committing suicide by now. As a mathematician, that's a very important margin of error. Who could be mistaken? Is it me? Is it me in my math? I was pretty good in math when I was in school. I went to college, and I was still pretty good in math. I remember even writing my best friend's math test after I was done with my own in class one time. So here, Robert, come on, Robert, what's up with you? What's up with this number here? Because if we're using numbers in math, we should be winding up with an accurate answer. Look at these numbers, how accurate they are. Are we living on a globe Earth? On a ball like that? Seriously? I don't think so. Anyway, I got plenty more videos to show you about our Earth curvature, mostly in Hawaii. So stay tuned, and thank you for watching. Aloha.